Hi, it's Miss House. At the very end of class today, as we were running out of time, we were trying to finish this problem. The cosine of 2 theta equals the square root of 3 over 2. And we were really close to getting the final answer. So let's look at what we did first. We said we know that the cosine is the square root of 3 over 2 here at pi over 6. And we know the cosine is also the square root of 3 over 2 here at 11 pi over 6. Okay? Now, we also realize that we have an angle 2 theta, but we didn't consider that when we were looking at the other two angles. We were thinking that we're getting negative cosines when we really were not, because we were looking at the angle as theta and not 2 theta. So I'll show you what that means. We know that twice theta is pi over 6. And to find the other angles that are located in this same spot, you'd have to add 2 pi. So, and you could do that multiple times. So we'll write plus 2k pi. Now, they may not fit in our given interval, but we'll eliminate the ones that don't. They wanted us to go between 0 and 2 pi. And once we get the answers, we'll check, and you'll see that they check. So we said 2 theta is pi over 6, so we knew we had to divide by 2, but what we weren't considering is we have to also divide the 2 pi by 2. So it's really not 2 pi, it's pi, because look, this angle's doubled, so this is going to be, we're going to have to take half of everything, right? Just like here, we're dividing by 2, dividing by 2, dividing by 2, including the period. So theta gave us pi over 12 when we correctly identified that. So the actual angle, because of the 2 theta, is pi over 12. And then plus, since it's 2 theta, it's not going to be plus 2 pi, but it's going to be plus 1k pi. Okay? Now, once we start adding some versions of pi, if they come out more than 2 pi, we can stop. But we're going to see how many we can find between 0 and 2 pi in just a minute. But let's look at the second angle. 2 theta is 11 pi over 6 plus 2k pi. That's the period of cosine around and around and around. That's the k part, okay? But we have to divide by 2 because our angle is twice theta, and we came up with that angle 11 pi over 12 plus, now it's k pi. And we were looking at 11 pi over 12, and we're thinking the cosine is negative. But remember, it's not theta, it's 2 theta. Okay? And when you twice this, it's the one that ends up over here. Okay? Now, so we know 2 of them. We know pi over 12, and we know 11 pi over 12. Now, we have to see if there are any others that would still be within 2 pi. So let's let k equal 1. So that would be pi over 12 plus pi. Okay? And if you get a common denominator here, that's pi over 12 plus 12 pi over 12. Okay, 12 over 12 is 1 pi. So that's 13 pi over 12. Now you're thinking, okay, but that's here. No, it's not, because this is twice theta. We're saying theta is 13 pi over 12. But really, that's 13 pi. When it's twice theta, when you multiply that twice, we're not really looking at 13 pi over 12. We're looking at 26 pi over 12, right there. And we'll check those in just a minute. But look. So we're saying 13 pi over 12. Now that's less than 2 pi. That's 1/12 pi, so that's fine. Okay. Now if we go from here and add another 2 pi, or I'm sorry, another pi, then we're going to be more than 24. Because look, when we add 12 pi over 12, that's going to be 25 pi over 12, and that goes into there more than 2 times, so that can't be it. But let's look at this one now. So we've got 11 pi over 12 plus, let's go ahead and add pi, 1 where k is 1, and we get 11 pi over 12 plus 12 pi over 12, and that's 23 pi over 12. Well, guess what? That's right in here. So that is also an angle. Okay. Now, I'm going to check these and show you that we're thinking, okay, this can't be right because it's over here. Or this one can't be right because it's over here. But actually, we can check it and you'll see because of the 2 theta that we're correct. Okay. So I'm going to create a little space here. All right. So we're saying now that the cosine of 2 times pi over 12 is the square root of 3 over 2. Well, that's the cosine of pi over 6 is the square root of 3 over 2, and that's correct. Okay? We're saying that the cosine of 11, of twice, gotta remember, gotta twice it, of twice 11 pi over 12 is the square root of 3 over 2. Well, that's the cosine of 11 pi over 6. Well, that's 11 pi over 6. That's the square root of 3 over 2. So that one's also correct. Okay? So that was the thing we weren't paying attention to, is this is 2 theta. Not theta, but 2 theta. All right, let's check this next one, 13 pi over 12. The cosine of 13 pi over 12 times 2 is the cosine of 13 pi over 6. And the cosine of 13 pi over 6, so let's see, where would that be? Okay, it's not one that we normally look at too much, but let's look at that and see where it ends up. So we got a pi over 6. Okay. Now we've got to divide our unit circle into 6s. So look, 1, 2, see, pi over 6, that's pi over 4, this is 3 pi over 6, right? And then 4 pi over 6 is right here. And then 5 pi over 6 is right here. And 6 pi over 6 is right here. And then 7 pi over 6 is right here. And then 8 pi over 6 is here. 9 pi over 6 is here. 10 pi over 6, 11 pi over 6 is here. This is 12 pi over 6. And guess what? This is 13 pi over 6. So see, we are back at the square root of 3 over 2. So that is also the square root of 3 over 2 because it's the same as pi over 6. Right? And then the last one, 23 pi over 12. Okay. remember, again, it's not the cosine of 23 pi over 12. It's the cosine of twice 23 pi over 12. Well, that's the cosine of 23 pi over 6. All right? Now think about your evens and odds of pi. You've got odd here and even here, okay? And 6 goes into 23 3 times with 5/6 left over, okay? So it's 3 and 5/6 pi. So look, here's 0, 1, 2, 3, and 5/6 is, look, right there. So here's your 23 pi over 6. So that's also the square root of 3 over 2. So we were absolutely on the right track. The only thing we were not considering is that they were asking us for the cosine of twice theta, and I was treating our angles as theta. Remember, we were looking at those angles that we found, pi over 12 and 11 pi over 12 as theta, but remember, it's twice. So always approach it the same way. Look at find the reference angles, the ones where you know that the cosine is, or sine or whatever is this, okay? And then add 2k pi. But if it's twice theta here, you got to divide everybody by 2, even the period. And that's the key here. And you just have to go around adding that, and then you have to check to see if it's within your given interval that they gave us, which was between 0 and 2 pi. So the final answers for that one, pi over 12, which we got, 11 pi over 12, which we got, and with this solution, we also know that 13 pi over 12, because when you twice it, will be a solution, and 23 pi over 12 will also be a solution. So I hope this helps, and we'll definitely do a few more of these in class on Tuesday.